Hey there, what do you know, space weather and Earth weather enthusiasts? Welcome to the Daily Space and Earth Weather. We'll be talking about all kinds of facts, maybe even saying some things that are controversial. And thanks for tuning in and stargazing with us. We are starting things out looking at Iron Star here. This is 3 different wavelengths from the SDO. 335, 193, and 94 are all ionized species of iron. We did see a C6 flare from this area down here, and our regular viewers would be well aware that large solar flares are more likely around the limbs as opposed to in the center of the solar disk. This is your colorized magnetogram. We've seen a slight downtick here in solar activity over the past few days. No major changes with sunspots at the moment. No new sunspots to report. Let's briefly take a look at seismicity here. We are seeing an earthquake drought, a very low number of 7+ magnitude quakes. Largest quake of the past 24 was this 5.9 at Myanmar. It may always be Burma to you, but now it's known as Myanmar. So there was a location of that there north of Thailand, and that came in at 17:07 yesterday evening. Let's scroll up the list here. No major quakes, but keep in mind, folks, any earthquake can be a foreshock. So again, we are seeing a 7 magnitude earthquake drought, and we implore you to be an asset, not a liability, in the event of a disaster. There also was a 5.2 in the South Sandwich Islands region and a 5.2 at Japan. So quite low seismic activity the past few days, and indeed the past 90 days. Again, a 7+ magnitude earthquake drought continues. Let's check volcanoes before we get back to the realm of space. We'll close out the video with some Earth weather. So Shiveluch continues to erupt on the Kamchatka Peninsula. It's producing a 17,000-foot plume of volcanic ash, flight level 170 over Kamchatka as a result of the explosive activity and ash production from Shiveluch. Fuego exploding as well, 15,000-foot ash plume from Fuego. That's located in Guatemala. Moving farther south to Colombia, we see Nevado del Ruiz continues to explode. It's producing a 23,000-foot plume of volcanic ash, flight level 230 over Colombia. In Ecuador, Sangay exploding, flight level 220 from Sangay. A 22,000-foot ash plume and a 24,000-foot ash plume from Sabancaya in Peru. As Sabancaya explodes, please don't pole vault the caldera. It could be an unhealthful activity. Let's get back to space. So here is another composite series of images that we've compiled from helioviewer.org. 171 and 335 angstroms. A great mixture there of different portions of the corona and chromosphere. And let's move to ionized helium. Again, there was a C6 flare, which we'll look at in a few moments. So here's ionized helium. And we've got NOAA forecasting some arrivals of coronal mass ejection strikes. We'll get to that in a moment. And the radio flux now down to 122 solar flux units. Here is the 1-year chart of the radio flux. It's that black line. And we're watching this ramp up of solar cycle 25. Still got a couple years before reaching solar maximum, we expect. So here's your space weather enthusiast dashboard. Again, NOAA forecasting a KP6 G2 level geomagnetic storm early in the day tomorrow. It should be right around when we're creating our video, so we'll see what happens. NOAA expecting the arrival of a coronal mass ejection strike from yesterday, which we did cover. I didn't think there was an earthly component, but apparently NOAA disagrees, so we'll just have to see what happens. I would expect it to be a glancing blow, if anything. Let's take a look at the earthly geospace here. Here's Earth's magnetic moment from space out to about 12 Earth diameters. It's the magnetohydrodynamic pressure. And over the last 4 hours, we have seen some fairly high-speed coronal hole winds. Again, that's the last 4 hours of magnetohydrodynamic pressure surrounding the planet. Moving to the ground magnetic perturbations map. This is Earth's magnetic moment from the ground. This is nanotesla, the scale on this, magnetic flux density. And we did see some geomagnetic storm conditions yesterday. But this is the last 4 hours. Let's let that play through to show the full run. Keep in mind, folks, this data is not accessible in archival format. That's why we show it daily. And thanks to everybody who's tuned in to our daily space weather videos the past 5 years, the most in-depth space weather videos and most detailed views of the sun you'll find anywhere on the internet. Congratulations on realizing the channel exists. So there's that brief geomagnetic storm conditions. We saw a very strong magnetic field associated with the first portion of the high-density portion of the coronal hole wind stream. Current conditions are KP3. We do have an elevated solar wind speed. But around this time, we saw quite strong magnetic fields here. You can see up there in the top frame, that white line, 19 nanotesla. That was about as strong as it got. It got up to, well, it got up to 21 there. 21 nanotesla. Solar wind density made it up to about 34. We actually sent out an alert at smashomash.com/smashteam. Current conditions are, and the solar wind did make it up to about 560 kilometers per second. Well, 552 kilometers per second. There's a pretty high reading. Current conditions are ramped down a little bit, still over 500 kilometers per second there. Solar wind density about 9 protons per cubic centimeter. I would also note this great signal here with the plasma temperature. So on this bottom frame here, you can see this really good signal there. That's a great signal for the coronal hole high-speed stream that is still currently striking Earth's magnetosphere. Here you can see a strong magnetic reading showing up there on the GOES 16 and GOES 17, making it up to 187 nanotesla. Much calmer now. That's the GOES magnetometers over the past 3 days, and let's take a look at the heliospheric current sheet. Earth remains in a South Pole current sheet. No expectation of sudden changes to that based on what we see on the sun. Next, we'll look at the line of sight field plot here. The sun's B field shown here in blue, also the solar magnetogram. You can see the solar polar fields there. Red for south, green for north. Let's move to coronal holes, as we've got a series of South Pole-oriented coronal holes, some of which are trans-equatorial. Those are the most geo-effective ones. They're the most likely coronal holes to produce the kind of coronal hole wind stream that we're currently seeing. Seeing is believing, and let's take a look at 193 angstroms. And these additional coronal holes we see over here, they're all South Pole oriented. So that's the current state of affairs over the past 24 hours. These HelioViewer movies that we typically show are 24 hours or so. And let's move to sunspots. We've got some great imagery of that once again as well. So likelihood of solar flares, not as high as it was, but we do have some setting sunspot groups. So this group here, 3057, is quite a large group, and it's actually likely to produce some large flares here. So we'll see what happens. Again, flares more likely, especially large flares more likely, as sunspots reach the limb of the sun. An indication of the angular aspects of photon. They are anisotropic, apparently. Solar flare production. And of course, we need an X-ray imager out at Stereo B. That would be great. A new Stereo B, complete with an X-ray imager, to help corroborate the fact that solar flares are more likely, especially large ones, around the limb. Much more likely, in fact. So here is your SDO continuum imagery. That's visible light. And here's a close-up. Again, I would say the most likely spot to see a large flare would be from this sunspot group up here. And let's throw in 1700 angstroms to add a little bit of color. And 1700 angstroms is just a portion of the extreme ultraviolet light spectrum, not visible from the ground level, but it is visible from the SDO, which is what we're showing. So, just additional spectacular imagery there from the Smash News Network, least busted name in news. And let's take a look at flaring here over the past 3 days. There is your 3-day X-ray profile. Again, we did see a C6 flare that occurred at just before midnight at 2340 yesterday on July 21st. It was short-lived. And you'll see it down here in the southwestern corner. Decent-sized C-class flare there. And let's let that run through one more time. And for you new viewers, 94 angstroms and 131 angstroms are the best wavelengths to view solar flares. They take 10 images per minute instead of only 2 images per minute. It's a 5 times higher temporal resolution. Here's the proton flux, and no relativistic particles showing up as a result of any of that activity. And of course, we always encourage our viewers to look up. If you're up before dawn, you may see Saturn, Jupiter, Mars, the Moon, and Venus all rising ahead of the Sun. This star chart is from in-the-sky.org, and that is the all-sky chart. Just put in your location if you want to see what's going on above your head. I like to face mine to the south. That's the direction of the ecliptic from the northern hemisphere. Let's take a look at the solar system forecast. Keep in mind, folks, this is not to scale, and keep in mind that planets are not going to kill you. But let's advance this 1 week as Mercury swings around from the far side of the Sun. Here's where things will be in a week. We'll be right around a new moon, encouraging all of our reverse werewolves to sleep well and be productive members of society who do not cannibalize humans, stay up all night, or do other idiotic things. Next, moving to coronagraphs. You can see this coronal mass ejection. This is the one that NOAA is expecting to strike with a little high-speed burst. And there was indeed a high-speed burst from this one. That could include a small earthly component, but I don't know why they're expecting such a lengthy geomagnetic storm condition. Anyway, that's yesterday's coronagraphs. We'll also bring up today's. This is today so far. There are some additional CMEs showing up there. They're pretty minor, and I think they're on the far side of the Sun. So let's take a look at the view from Stereo A, which is now back with the current data, located here at Lagrange 5, and the SOHO-LASCO C3, located here at Lagrange 1. So there you can see yesterday's CME. Most of the material certainly will miss the Earth to the east and north. And you can see really no ejecta headed down the earthly pipeline here from the perspective of Stereo A. So you can see Stereo A is located at Lagrange 5. Once again, folks, and for you new viewers, Earth would be off in the direction of that arrow. From SOHO-LASCO C3's perspective, Earth would be behind your view, as it is located at Lagrange point 1. And it doesn't look like any additional ejecta headed toward the Earth. What you're seeing there on the SOHO-LASCO C3 is kind of on the far side, or kind of coming out of the North Polar region there. Not likely to be earthly oriented. So we've got plenty more to cover here. Some more spectacular imagery of the closest star. Here's the hydrogen alpha imagery from El Teide, Spain. And once again, we've got quite a lot of filaments here. You can see filaments down here, filaments, filaments, and filaments. Remember, folks, we don't need to see coronal mass. We don't need to see solar flares or sunspots to see coronal mass ejections. We started covering the daily space weather just before the most recent solar minimum. And we covered coronal mass ejections on the regs and even learned to forecast them. So here is the NASA GOES 16 SUVI imagery for the past couple of hours. The great wide field of view is fantastic for showing coronal mass ejections. It's got a lower resolution than the SDO, but a wider field of view because, hey, in the real world, you got to give up something to get something else. So here's the higher resolution imagery. This is ionized iron, 171 angstroms, the house favorite wavelength from SDO, and you can see the higher resolution there, and the narrower field of view. That's the last 24 hours on our HelioViewer movie. And let's go to the realm of bonus features. We've got some electron anomalies happening. And here's your total electron content forecast, and you're going to see crazy anomalies around the Southern Ocean here. It's like a little miniature Van Allen belt has formed down there briefly. We'll let that play through again. Total electron content forecast shows the coupled thermosphere, ionosphere, plasmasphere electrodynamics. We'll let that run through a third time. Again, because we've got huge concentrations of electrons a bit out of place there, showing up around the southern Indian Ocean, the South Atlantic, and around Antarctica. Your GPS satellite is located at about 12,500 miles of altitude, and that total electron content forecast shows you the most likely areas for GPS errors. Looking at the satellite's community dashboard, we're seeing some surface charging hazards here. This is from low-energy electrons building up on the surfaces of spacecraft. We've got some significant charging hazards here around Mexico, Central America, and moving into the Central Pacific Ocean. That's your satellite charging hazards report. You could see some minor communications breakdowns from satellites in those areas. Here's your GOES electron flux over the past 3 days. We're actually seeing kind of high levels of electron flux considering there is a coronal hole wind stream striking at the moment. And here is the NOAA forecast model. I would tend to agree with this forecast. No arguments there. The green boxes of the forecast, the yellow diamonds, are not lucky charms. Those are the observations. Here's the one-year chart from Solon.info to put the relativistic electrons in context. And we'll also take a look at the F-ionosphere layer, the bridge between Earth and space. As we get closer to Earth and to our meteorology segment, this is what's going on overhead at about 300 kilometers of altitude, the F-ionosphere layer in vibrational frequency. And we're certainly seeing some low-frequency anomalies happening here around the Central Atlantic and South American region. We'll show the anomalygram to put that in context. So here's the anomalygram. You can expect to see some red here, right around this area. Maybe less than I expected, but anyway, that's the anomaly in megahertz from 30-day median. Quite a few high-frequency anomalies happening there as well. Let's show the latest image as we do daily on the channel. Just citing fact after fact. There is the 10 o'clock universal time ionogram and the 10 o'clock universal time anomalygram. Next, as we do daily, we'll show the latest intensitygram and latest colorized magnetogram. Minor degradation here of sunspots, no new sunspots. Once again, the most likely place to see major flares, I believe, is from this group right here. I think it's 3057, if I remember correctly. Don't quote me on it. Or do. It's fine with me. And let's take a look at one more composite image of the sun here before we move to the realm of meteorology. So this is two species of ionized iron, that's 211 and 171 angstroms, and one species of ionized helium, 304 angstroms. Just keep in mind that 211 and 171 are in different colors than normally shown on the SDO. 211 is shown here in green and 171 is shown here in blue. And it's a great lively composite series of images there from the SDO Browse Data section. Continuing to the realm of meteorology, as hot temperatures are a focus of a lot of news attention. We're not biased on the channel, so we focus on all of the news, and we look at things from an objective perspective. Objective perspective, here, at the Smash News Network, least busted name in news. It's winter in Antarctica. And it's not exactly what you would call hot in Greenland. So let's move to the east side for all of our viewers from under and from over the equator. We're going to show the 250 hectopascal winds, otherwise known as the jet streams. Huge kink in the jet stream here east of Australia, and some chaotic jet streams for sure in the northern hemisphere, as it's hot up there, and that does not lead to concentrated jet streams. You can see the difference between winter and summer. Remember, folks, cold air is more massive than warm air, the same way dry air is more massive than moist air. Continuing on to our surface winds. There you have it. We're also going to look at waves later in the video. We'll show you the biggest surf in the world. Here are the surface winds of the Americas. Huge convective forces still at play in the southern U.S. You can see south to north winds happening here over southern Texas, for example. Here are the jet streams of the Americas. We still do have an anticyclone here over the southwestern U.S. That is a high pressure zone and likely featuring clear skies and definitely featuring a clockwise rotation. As you see with anticyclones in the northern hemisphere, here are the jet streams of Europe, Africa, and the Middle East, and the jet stream blowing backwards there over the northern Indian Ocean, most of the Indian Ocean, in fact. And you can see a 180-degree bend here, just east of Madagascar. Last but not least, these are the surface winds, like sands through the hourglass of time. Those are the surface winds of the central world. And let's blast through some more data here. We don't want the video to be too long. Here is the weather.gov map. Looks like we've got some gale warnings there around Alaska. We've got some excessive heat warnings here for the southwest. It is a heat dome anticyclone, as the jet stream is staying north of that area. Also some heat advisories around the mid-Atlantic states, New England, and the central U.S. there, centered on places like Missouri. Here's your temperature anomaly forecast based on the GFS model, and some wild swings of temperature happening there. Some huge low temperature and high temperature anomalies. We're expecting 100 degrees on Sunday last we checked. If you're wondering where we're located, it's right about here in Lehigh Valley, Pennsylvania, U.S. Right about there, just west of New Jersey. Again, that's your 72-hour temperature anomaly forecast. Keep in mind, temperatures are shown here in degrees Celsius. Next, moving to your lightning mapper, and geez, Alabama and Mississippi saw some serious lightning here, which then moved into New Orleans. July, the most active lightning month of the year. And let's take a look at a real-time lightning map from lightningmaps.org. First, let me just check the life of the stream here, and thanks for leaving comments, TinMan1057. Good morning to you as well. And Sir Giddy615, who wants us to name the part of the segment graham crackers. I don't know why. And the reason that, well, the best demonstration of why cold air is more massive than warm air is the same reason a hot air balloon floats. Hopefully that makes sense. Back to our real-time lightning map here. The reason dry air is more massive than moist air is because atmospheric nitrogen is simply more massive than atmospheric water vapor. That's why a clear day features higher pressure than a cloudy, stormy day. Anyway, there's your real-time lightning map. We do have some terrestrial lightning in the U.S. Let's zoom in. It looks like the Carolinas. Baton Rouge. Yowzers. There is a strong cell here to your northeast. That is a lot of lightning showing up there around Baton Rouge. Lightningmaps.org does enable you to forecast thunder. You can frighten the natives, maybe convince them that you're Thor or Odin or something like that. And let's move on to our GFS pressure and precipitation forecast for the lower 48. This is the next 72 hours of pressure and precipitation based on the GFS model. Expecting some strong storms here around Minnesota and Wisconsin once again. The Great Lakes there, expecting to see some serious weather and some compartmentalized strong storms here in the southern U.S., also in the southwest. Some red showing up there on the GFS pressure and precipitation forecast. It's the next 72 hours, and these are pretty likely. These models are within an appropriate amount of time. So here is your windy.com wave report. And we've got 24-footers here on eastern Australia. Shout out to Kimberly. If you'd like to go surfing, today might be a good time to do it. 24-foot waves are no joke. And yeah, there you go. I think that is the location for the best surf on the planet. Windy.com, they got a great mobile app. It's free to download, and we're not paid yet to tell you that. In fact, we're paid just this side of nothing to make the videos, period. Here's your U.S. Doppler radar map. And we're going to focus on the lower 48 here. And before we continue on, this video was originally streamed live to Twitch. Twitch.tv/SmashAmash is where we regularly stream live. Today's featured product is the Galactic Federation Special Forces, where we say Universum Libertate. It is a message of personal freedom and liberty. Universum Libertate. If I could wave my magic wand, I'd set everybody free. Don't forget, folks, it's on you to love people who you dislike. So Universum Libertate, if you're wondering what the symbolism means, the spiral represents the Milky Way galaxy. The key represents signal strength and security, and the lightning bolt represents instantaneous galactic scale reach. This little bright spot up here, that's classified. But once again, Universum Libertate. And of course, we wear the products ourselves. There are other products available as well at the Redbubble shop. So check them out. You can find links below the video as well as on our homepage at smashomash.com. Thanks to all of our new YouTube subscribers. If you're new to the channel, press like and subscribe. Tell your friends and foes. Press that share button. If you're an influencer or a large channel, let us know. We will be more than happy to feature you on the channel or to appear on yours. If you want to support the channel via subscription services, smashomash.com/SmashTeam. We created our own because Patreon did not have the capabilities we needed. Smashomash.com/SmashTeam did. We built it ourselves. Shout out to Smash staff. Give her a raise by becoming a gold or silver member. Thanks to those who have supported the channel throughout the years. We are still on Patreon as well. If you'd like to support us that way, feel free. Once again, links at the homepage at smashomash.com. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade of the Internet Underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you could hire the Smash Team. In any case, welcome to the Neo-Renaissance. Here's the rest of your meteorological data for the day. This is your shortwave radiation map, 3.9 nanometers infrared. From the NASA GOES Interactive Weather Satellite Suite, it shows clouds and fog when it's too dark to use the visible satellite. And we will close out with the water vapor map. So there you have it. We've got a weak low pressure system right here. So people might be freaking out about this. You can see this counterclockwise rotation. but it's a bunch of dry, massive air there, so not a lot of moisture. That will not aid to convection, as that is a high-pressure zone. And thanks for tuning in to the Daily Space Weather and Meteorological Information segment here at the Smash News Network, least busted name in news. We'll talk to you soon, and may that solar wind be at your back.